Good morning, everyone. Our topic for today is all about the fundamental concepts of electromagnetic waves. This topic includes the definition of EM waves, its different kinds, the electromagnetic spectrum, and the relationship between the energy, frequency, and wavelength. So, let's start our discussion. What is EM waves? Electromagnetic wave is one of the waves propagated by simultaneous periodic variations of electric and magnetic field intensity. It includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. These waves will be discussed in the following slides. What are the kinds of EM waves? Let's start with radio waves. Radio waves is produced by the accelerated motion of charges in conducting wires. It is also used in radio and television communication systems, and it is also an electromagnetic wave that is used for sending signals through the air without using wires. Next is the microwaves. Microwaves are a very short wave of electromagnetic wave. Microwave ovens are an interesting domestic application of these waves, and due to its short wavelengths, it is suitable for the radar systems used in aircraft navigation. Next is the infrared waves. Using rays of light that cannot be seen and that are longer rays that produce red light. It plays an important role in maintaining the Earth's warmth or average temperature through the greenhouse effect. Infrared waves are produced by hot bodies and molecules. Let's come now to visible light. Visible light is the part of spectrum that's detected by the human eye. Visible light emitted or reflected from the objects around us and provides us information about the world. Our eyes are sensitive to this range of wavelength. So, in the electromagnetic wave spectrum, visible light is the only wave which our eye, the human eye, could see. Okay, next, the ultraviolet rays. The rays of light cannot be seen and that are slightly shorter than the rays of violet lights. Ultraviolet or UV radiation is produced by special lamps and very hot bodies. Well, there's a survival video that I've watched, and they use special ultraviolet lamps to kill or to purify the water so that they could drink it safely. Next is the sun. Our very own sun is an important source of ultraviolet light. Okay, let's continue. Number 6 is the X-rays. I know that almost everyone is familiar with this kind of rays. We often hear it at soft operas, movies. Now, X-rays is a powerful invisible rays that can pass through various objects and that can make possible to see inside things. Also, it has the property of penetrating various thicknesses of all solids, of producing secondary radiations by impinging on material bodies, and of acting on photographic films and plate as light dust. X-rays is also used as diagnostic tool in medical treatment. Let's focus on the gamma rays. Gamma rays is a high-frequency radiation. It is produced in nuclear reaction and also emitted by radioactive nuclei. Just like the X-ray, gamma rays has also clinical or medical uses. They are used in medicine to destroy cancer cells. Let's come now to the electromagnetic spectrum. This is a diagram of the electromagnetic spectrum. The bottom of this spectrum is where radio waves are found, followed by microwaves, infrared, visible light, ultraviolet rays, X-rays, and gamma rays. Now, it is observable that each waves has different frequencies and the different length of the wave or the wavelength. The upper part of this wave are called crest or the upper point. The distance between these points, these two crests, is what we called wavelength. Now, what is the relationship between the energy, the frequency, and the wavelength? As the energy increases, the frequency of the wave also increases. What is the frequency? The frequency is the number of waves. So let's see. Since the radio wave has the lowest energy, it has also the lowest number of waves, or it has the lowest frequency. Now, what is the relationship of these two with the wavelength? Well, energy and frequency is inversely proportional with the wavelength, meaning as energy increases, wavelength decreases. As frequency increases, the wavelength also decreases. But when the energy increases, the frequency also increases. That is the electromagnetic spectrum. Okay? So that would be all. Thank you for listening.